From cyclones that stretch across entire continents to these surgical strikes of pure wind, storms are, without a doubt, some of the most powerful forces on our planet. They really do shape our world, and they're a constant reminder of nature's raw power. So in this explainer, we're going to break down the science behind Earth's most destructive storms.
This quote, it just perfectly captures it, doesn't it? It gets right to the heart of the matter. What we're talking about is this huge gap between how vulnerable we are and the unbelievable, unpredictable power of the atmosphere. It's a really humbling thought, and it kind of sets the stage for the forces we're about to explore. All right, let's kick things off with the titans of wind. These are the storms that are defined by the incredible speed and just the sheer force of the air itself. These are the ones we all think of first when we imagine pure atmospheric violence. And first up, of course, is the icon of destructive storms, the tropical cyclone. Now, you might know them as hurricanes if you're in the Atlantic, or typhoons in the Pacific, maybe cyclones in the Indian Ocean, but they are all the same beast. At its core, it's a gigantic, rotating heat engine, and its fuel is warm ocean water.
But here's the thing about a cyclone. Its arsenal is way more than just wind. Yeah, the speeds can get up over 300 kilometers an hour, which is terrifying. But the real catastrophe, that often comes from the storm surge that just swallows coastlines whole, or the extreme inland flooding when these systems slow down and dump unimaginable amounts of rain.
Now, let's talk about a completely different kind of windstorm, the tornado. Unlike a huge, sprawling cyclone, a tornado is this focused, incredibly violent column of air. It's usually born from a powerful, rotating thunderstorm we call a supercell. It is, literally, a concentrated vortex of pure destruction.
And when you put them side by side, the differences are just stark. A cyclone is immense, right? It can span thousands of kilometers and last for days, which at least gives us some advance warning. A tornado, though, it's localized and it's over in a flash. We're talking minutes. It's all about surgical precision, with almost no warning time at all.
480 kilometers per hour. Just let that number sink in. That is the fastest wind speed ever recorded on our planet. It's a speed that's honestly hard to even imagine. And that is why tornadoes, despite their small size and short lifespan, can carve such utterly devastating paths.
Okay, so we're going to shift focus now. We've talked about wind, but let's move on to water. Because for this next category of storms, the primary weapon isn't velocity, it's volume. It's about an overwhelming, catastrophic amount of water falling from the sky.
And our first example is a phenomenon with such a great descriptive name, the atmospheric river. And it is exactly what it sounds like, a long, narrow channel of moisture flowing way up in the atmosphere. Seriously, just picture a massive fire hose in the sky, aimed right at the land. And the scale of this is just staggering. Get this, a single, strong atmospheric river can carry more water vapor than the Amazon River. So you can imagine what happens when that river in the sky makes landfall. It can trigger absolutely catastrophic floods and landslides.
Next up, the monsoon. Now, this isn't really a single storm. It's a massive seasonal shift in wind and rain that affects huge parts of the globe, especially places like South Asia. For billions of people, the monsoon is literally life itself. It brings the water they need for agriculture. But that reliance comes with a terrible risk.
And here is that dual threat. The danger of the monsoon is all in its variability. If it's too intense, you get catastrophic flooding that can displace millions. But if the monsoon fails, if it's too weak, the result is drought, crop failure, and potential famine. It's this delicate balance on a continental scale with devastating consequences at both extremes.
All right, for our final category, we're moving beyond wind and rain. We're going to explore the power of the planet's deep cold and the really complex dynamics that can bring that cold crashing right down on top of us.
So far, pretty much everything we've talked about has been fueled by heat. But destruction doesn't always come from warmth. Sometimes the most damaging weather events are actually born in the extreme cold of the Arctic.
And that brings us to the polar vortex. So normally, this is a stable, strong band of winds that basically keeps the coldest air on Earth locked up over the Arctic. A disruption is what happens when that vortex weakens, or it wobbles, or it splits. Essentially, someone opens the planet's freezer door and all that frigid air comes spilling south. So here's how it happens. First, you have that stable vortex, keeping the cold contained where it belongs. Then, something causes it to weaken and become unstable.
And the result is this massive outbreak of Arctic air just plunging into regions that are totally unprepared for it, causing catastrophic infrastructure failures, like what we saw in Texas back in 2021.
So, we've looked at storms of wind, storms of water, and storms of ice. Now, to wrap this all up, let's zoom out and look at the single powerful thread that connects all of these phenomena and is shaping their future.
And this brings us to the most crucial takeaway of all. A warming planet isn't necessarily creating new types of storms. What it's doing is acting as an amplifier. It's taking these natural systems that have always existed and just turning up their destructive potential.
And you can see the connections so clearly. Warmer oceans? Well, that's just more fuel for stronger cyclones. A warmer atmosphere? That can hold more moisture, which supercharges things like atmospheric rivers. Rising sea levels give storm surges a higher launch pad to begin with, and, paradoxically, a warming Arctic may be making that polar vortex even less stable. It's a systemic amplification of risk across the board.
This final quote, it just hits the nail on the head. The storms themselves are natural. The physics behind them has always been there. But their destructiveness, the impact they have on us, that's being amplified by human factors, both through climate change and, frankly, by where and how we choose to build our community.
And that leaves us with one final critical thought. Storms are an inevitable part of living on this dynamic planet of ours. They are always going to come. The really pressing question for our future is whether we'll have the foresight, the technology, and the collective will to be ready when they do.